Hello students, today we are going to discuss about the exam conducted on 15th of this month. Answer the first question. A person can see the objects kept at a distance beyond 100 centimeters. Find the nature and the power of the lens to be used for seeing clearly the object at a distance. So here observe that the object distance, the person cannot see beyond the person cannot see beyond 100 centimeters. Based on that, here we can represent that the image distance as b equals to minus red centimeters and u is equals to infinity. Based on that, when we consider the focal length equation, here we know that 1 by f equals to 1 by b minus 1 by u. So when we substitute the values here, also the minus 1 by 100 and minus of plus 1 by 100. So here we can represent that 1 by equals to minus 1 by 100. So we can represent that f is equals to minus 100 centimeters. The power of the lens is being represented as p equals to minus 1 by, or in terms of centimeters, we can represent it as 100 by nothing but minus 1D is the power of the lens. And here, since here minus sign is being represented, we can represent it as a concave lens. So the next question. A man can see the objects clearly up to 3 meters. What should be the focal length of the lens to see clearly up to 12 meters? Here, the here as you consider this condition, here we can represent that the image distance is represented as minus 3 meters because he can see the objects are clearly up to 3 meters, whereas the object distance is being represented as minus 12 meters. Then by using the focal length equation here, we can represent 1 by f is equals to 1 by b minus 1 by 2. Then here we can represent as minus 1 by 3 plus 1 by 2. And simplifying here, we get that f is equals to minus 4. So option is 1. Also the next question. If a far-sighted person cannot see objects placed closer to 50 centimeters, find the power of the lens needed to see the object at 20 centimeters. So here the far-sighted person cannot see the objects placed closer to 50 centimeters. Based on that, here we can represent that V is equals to minus 50 centimeters and U is equals to 20 centimeters. By using the focal length equation, we will get 1 by M equals to 1 by V minus 1. Here will be represented as minus 1 by 50 minus of minus plus 1 by 50. Then the focal length equation can be represented as 1 by F equals to 3 by 100. Then we know that the power of the lens can be represented as 100. So we can represent it as 3. So option is B. Option is after that, next question. A far-sighted person can see objects beyond a 69 centimeter clearly if the separation between glasses and eye lens is a 3 centimeter. Then find out the focal length of the glasses. So here, if the object cannot be seen beyond a 69 centimeters, so then the image distance can be represented as minus of a 69 centimeters. And here, and eye length is a 30 centimeters. So here we can represent it as a minus of 69 minus 30, which is equals to minus 66 centimeters. Then the focal length equation can be represented as 1 by f equals to 1 by v minus 1 by u, which is equals to minus 1 by 66 plus 1 by 25. So here we get f is equals to 40.2 centimeters. So option is D. Answer the next question. An object is seen through a simple microscope. An object is seen through a simple microscope. A focal length of 12 centimeter. Find the angular magnification produced if the image is formed at a 60 centimeter away from the lens. So here observe that the image is formed at a 60 centimeter. So here we can represent that V is equals to minus 60 centimeter and U has to be derived so that the object distance has to be represented, whereas the focal length of the lens has been represented as 12 centimeter. So by using the equation 1 by f equals to 1 by v minus 1 by u, here we can represent that 1 by 12 is equals to minus 1 by 60 minus 1. So here we can represent u is equals to minus 10 centimeters. So object is placed at 10 centimeters. But here we have to represent angular magnification, where angular magnification is being represented as a d by u, which is equals to 25 by 10. So it can be represented as a 2.5. So option is B. After the next question. Angular magnification of a simple microscope is 4x. Find the position of the object. So here, based on that, the magnification can be represented as a magnifying power equals to 4, which is equals to d by. Based on that, here the object distance can be represented as a d by magnifying power. So it can be represented as 25 by 4. So option is B. Observe the next question. Focal length of an objective of a compound microscope is. Focal length of objective of a compound microscope is 4 millimeters, and its image is formed by objective lens at a distance of 224 millimeters. If angular magnification is 550, then find out the focal length of the eye piece if finally image is formed at infinity. So here observe that the image distance is being represented as 224 millimeters, and focal length of the lens has been given as 4 millimeters. Based on that, here we can substitute these values in a focal length expression 1 by f equals 1 by v minus 1 by u, and the values are 1 by 224 minus 1 by u is equals to 1 by 4. And simplifying here, you get u is equals to minus 224 by 55 millimeters is the object distance. But here we have to find out the focal length of eyepiece, whereas a magnifying power of a compound microscope is given as a magnification of objective lens into magnification of eyepiece. Then magnification of eyepiece is equal to m by m naught, which is equal to pi 50 by 50 by 5 into 20. So based on that, the magnifying power of the eyepiece is being represented based on the focal length. So the focal length of the eyepiece is given as p equals to 2.5 centimeters. And this is being represented based on the equation of a magnifying of the objective length, where objective length is being given as a V naught by which is equal to 224 by 224 by 55. So your magnification of the objective length is a 55 millimeters. So option is 2. After that, next question. A compound microscope has an objective lens and eyepiece of focal length 2 centimeter and a 6.25 centimeter respectively, separated by a distance of 15 centimeters. Find out the magnifying power of a compound microscope in order to get the final image at the least distance of a distant vision. So here we are going to consider the objective lens and the eyepiece. These two are being separated by a distance of 15 centimeters. Whereas the object is being formed at a distance of V naught equals to 10 centimeters. And here the image distance for object distance for eyepiece will be 5 centimeters. So why? Because the image is formed due to the objective lens at a distance of 10 centimeters. Now we have to find out the objective distance. So when we consider this condition, we have represented it as a 15 centimeter. In centimeter. So based on that, here the magnifying power of the objective lens is being represented as m naught equals to f naught minus v naught by f naught. So here it can be represented as a 2 minus 10 by 2, which is equals to minus 2. Whereas the image distance for the eyepiece is being represented as minus 25 centimeters. Then here we can represent that 1 by V minus 1 by V equals to 1 by FE. Then here can be represented as minus 1 by 25 minus by V equals to 1 by 6.2. Based on that, here we had represented object is in front of the objective lens at a distance of 5 centimeters. Then magnifying power of the eyepiece is being represented as m equals to 1 plus d by f, which is equal to 1 plus 25 by 6.25, which is equal to 5. This represents the magnifying power of eyepiece, whereas the magnifying power is represented as m naught into m e, which is equal to minus 4 into 5. So it's equal to minus 2. So option is B. Observe the next question. Observe the next question. Here, the focal length of the objective and the eyepiece, eye lenses of a telescope are respectively given as 200 and 5 centimeters. The maximum magnifying power of the telescope. Here, focal length of the objective lens is being given as 200 centimeters, and focal length of the eyepiece is being given as 4 centimeters. Then, here the maximum magnifying power is being given as m max is equals to minus f naught by f e into 1 plus f e by t. So here it can represent as a minus 200 by 5 into 1 plus 5 by 25. So on simplifying here, we get a minus 48. So option is observe the next question. An astronomical telescope has an objective of focal length 200 centimeters and an eyepiece of focal length 4 centimeters. If this telescope is used to see 50-meter tall building at a distance of 2 kilometers, what is the angular size of the final image formed at a normal adjustment? So here focal length of the objective lens has been given as 200 centimeters and focal length of the eyepiece is being given as 4 centimeters. Since the height of the object is given as 50 meters and the object is at a distance of 2 kilometers. 2 kilometers can be represented as 2000 meters. So since object is distance is very much greater than focal length, here we can represent that object distance is equal to infinity. We are assuming that it has a infinity. Based on that, here we can represent the magnification made angle made by the lens. So that here when we consider the objective lens along with the eyepiece. So here the object is being the place of this distance. So the rays passing through this will form the image like this, and the rays will pass like this. So observe that the angular dispersion is considered as beta and the angular dispersion is alpha. Then magnifying power is being represented as a beta by alpha, which is equal to f naught by f e. Then by substituting the values, so that beta by the value of alpha is being given as alpha equals to 50, 50 meters by distance h naught by u naught. Then here it can be represented as 2000. So here we get that 1 by 40 is the value of alpha angle made by the object with respect to objective length h naught by u. Then observe that beta by 1 by 40 is equal to focal length of objective lens is 200 and focal length of eyepiece is, and simplifying here we get the beta equals to 1.25. So option is B. Observe the next question. If tube length of an astronomical telescope if a tube length of an astronomical telescope is 105 centimeter and its magnifying power is 20 for normal setting. Normal setting. Calculate the focal length of the object. Here the magnifying power has been given as 20 and the tube length L is equals to 105 centimeters. And here we know that L is equals to F naught plus FV, which is equals to 105 centimeters. So, and we know that the magnifying power M is equals to minus F naught by FV. Then F naught is equals to M into F minus half M into F, which is equals to minus 20 into focal length of the eyepiece is being represented based on this equation. On simplifying here, we get the F naught equals to 100 centimeters. So option is 1. Also, the next question: a small telescope has an objective. A small telescope has an objective length of focal length of 140 centimeter. 140 centimeter, and an eyepiece of focal length of 5 centimeter. What is the magnifying power of the telescope for viewing distant objects when the telescope is in a normal adjustment? That is when the image is at a infinity. So here, since the image is being formed at infinity, we consider the object of focal length as a 140 centimeter, and the focal length of the eyepiece is being given as a 5 centimeters. Then magnifying power is given as m equals to minus f naught by v, which is equals to minus alpha multiplied by minus 1. We can represent it as 28. So option is D. Also, the next question: in a compound microscope, in a compound microscope, object is placed at a distance of in a compound microscope, object is placed at a distance of 6 centimeters. 6 centimeters from the objective lens of focal length of 5 centimeters, and focal length of the eyepiece is 10 centimeters. Find out magnifying power of compound microscope when the final image is formed at the least distance of distinct vision. So, as we consider that the magnifying power of the objective lens is being represented as F naught by F naught plus U naught, which is equal to 5 by 5 minus 6 is equal to minus 2. This represents the magnifying power of our objectives, whereas the magnifying power of the eyepiece is represented as 1 plus D by F, which is equal to 1 plus 25 by 10. So it can be represented as a 3.1. Whereas we have to find out the magnifying power. We know that magnifying power of a compound microscope is being represented as m naught into n. So we can represent as minus 5 into 3 point, nothing but minus 17.5. So option is D. Observe the next question. A card sheet is divided into square, each of 1 millimeter square is being viewed at a distance of 9 centimeters through a magnifying glass. A converging lens of focal length at 10 centimeter held close to the eye. What is the magnification produced by the lens? So magnifying power is being represented as P is equal to F by F plus U. So based on that here, we can represent it as 10 by 10 minus 9, since the object is being represented with minus. So we get it. So option is C. Also the next question, the mass number of nucleus is equal to mass the mass number of a nucleus is equal to the number of. So here we know that the mass of a nucleus is directly proportional to mass number. So here we can represent that it depends upon the nucleus it contains. And also the next question, radius of helium-24 nucleus is 3 Fermi. The radius of Palladium, lead nucleus will be. So here after that the expression for radius is being given as r equals to r naught into a to the power of 1 by. Then based on that here we can represent r2 by r1 is equals to a2 by a1 whole to the power of 1 by 3. Right? Then here it can be represented as a 2 naught 6 by 4 whole to the power of 1 by 3. So this represents the value of r2 into 3. On simplifying here, we get a 11.6 Fermi meter is the radius. So option is C. And next, also the next question here, isotopes are atoms having them. So as we consider that here, when we consider an atom, here this Z represents that number of electrons. Atomic number represents a number of electrons or number of protons. Whereas mass number represents the sum of protons and neutrons. So here when we consider that I but different number of protons. So based on that here we can represent that the option is 1. Also the next question, the mass and energy equivalent to 1 AMU is respectively. So based on that here we know that 1 AMU is equal to 1 by 12 of carbon C 6 and 12 atom. So based on that here we can represent it as 1 by 67 into 10 to the power of minus 27 ratio, or in terms of energy it can be represented as 930 mega electron volts. Observe the next question. If M comma Mn comma and Mp are the masses of X, Z, A nucleus, neutron and proton respectively, then here M represents the mass of the nucleus, whereas Mn represents mass of neutron and M suffix P represents mass of the proton. Based on that, here we can represent that M is always less than A minus Z into Mn plus A Z into M suffix P. So option is 1. Observe the next question. Calculate the binding energy of chlorine 1735. If mass of chlorine 1735 nucleus is 34.98 AMU, mass of the neutron is 1.0086665 AMU, and mass of proton is 1.007277 AMU. Based on that, the mass effect can be represented as delta M equals to Z into M suffix P plus A minus Z into M suffix N minus M. So when we substitute here the values of M suffix P and M suffix N and M, here the expression can be mass defect can be represented as 0.29967 AMU. Then the energy can be given as a delta M into C square, or it can be represented as 0.29967 into 931.5 mega electron volts. On simplifying here, we get a 279.92. Approximately, we can represent it as a 278.92. So option is 2. If M is the atomic mass and A is the mass number, packing fraction is being represented as M minus A by A. After the next question. Fission of nuclei is possible because the binding energy per nucleon in them is decreases with the mass number at a high mass number. So this represents the condition for fusion. And next, after the next question, the average binding energy per nucleon of a nucleus is order of 5. So here we know that the average binding energy is being represented based on 8 mega electron volts. Because we know that the minimum binding energy is 1.1 megaelectron volts, and here the maximum binding energy is being represented as 8.7 megaelectron volts. So based on the average value that we represented as 8 megaelectron volts. Observe that for effective nuclear force, the distance should be 10 to the power of minus 50 meters. And the after the last question, the mass effect in a nuclear fission reaction is 0.3%. What amount of energy will be liberated if 1 kg fusion reaction? So here we represent that delta M is equal to 0.3% of 1 kg. Then here delta M is equal to 3 by 1000 kg. Then energy equal to 3 by 1000 into 9 into 10 to the power of 16. And simplifying here, we got that 2.7 into 10 to the power of 14 joules. So option is 3. With this, we had covered all the top questions which were given in today's exam.